So today we're going to jump way over into chapter 8, and we're going to look at trigonometry. We used to call it trigonometry. But it has to do with the relationships of the length of the sides and the sizes of the angles of a triangle. So we developed these ratios that relate to these different relationships. We're particularly talking about right triangles in this case. You can apply this with a little more sophisticated formula. You can apply it to non-right triangles, but for today, in the next couple lessons, we're going to restrict it just to right triangles, because right triangles are special. In fact, we skipped the section on special right triangles, and that's something else all over again, because there are known relationships for like a 30, 60, 90, which is special, and 45, 45, 90. But we're going to just deal with generic right triangles and talk about relationships. If you had your calculator, you'd be able to punch some buttons, and if you've got access to something on your phone or your tablet or whatever, it may be something that you want to work with a little bit to try these things out. But there's value in what we're going to do here today, just in understanding how to set it up, or how to look at these things with right triangle relationships. So I'm going to put our screen on full screen, which means you'll have to look real hard here. This is, let's talk about labeling a triangle. In any right triangle, there are three angles like A, B, and C. And typically, for the purpose of labeling and discussion, we call the side opposite angle A, side A, and the side opposite angle B is side B, and the same thing for C. C is typically the hypotenuse. You can label it differently, but we're talking in the just sort of generic sense. C is the hypotenuse, and the other two are the legs of the right triangle. Now, if we're talking about a particular angle here, like angle A, then you can see this is the adjacent leg, this is the opposite leg. This is the hypotenuse, period, because this is the one across on the right angle. So this is hypotenuse. The adjacent leg is the one that touches the angle we're talking about. We're talking about this angle. And the opposite leg doesn't touch it. Okay, doesn't touch that up there. So it's the opposite. It's opposite of A, is side A, is the opposite leg. So purpose of that is to be able to recognize who's who, so we can apply these trig functions, trig ratios to it. So this one says, with respect to angle B, which is this angle here, you can see that side AC is opposite. Okay, this angle B. Side AC is opposite this angle. Side BC is adjacent. This is the angle. This is the adjacent side. And side AB is the hypotenuse. And the hypotenuse is the hypotenuse, which is the hypotenuse. That doesn't change. If we switch the angle that we're talking about, we have to switch our discussion. No longer is this the, let me go back. So this is the opposite side, right? When you're talking about this angle. But when you're talking about the other angle, now it's the adjacent side. It's the one that touches the angle. So this is the adjacent side. This is the opposite side. This is still the hypotenuse. So let me just put, that's the hypotenuse. It's the adjacent side. And this is the opposite side. I'm just going to use those three letters for a reason. And this is the reason. Orange horses always have orange ankles. And you can see those three letters. The O, the H, and the A repeated in different order. But we have those three letters. Orange horses always have orange ankles. Should make some sort of sense to you that orange horses always have orange ankles. That's at least something that we can say. If you had your calculator, if you're able to look at one on the phone or tablet or something, you will see sine, cosine, and tangent. They're in order. It'll be sine, cosine, and tangent usually on your screen. Sine, cosine, and tangent. So the orders are on your calculator, sine, cosine, tangent. And sine relates to orange horses, cosine relates to always have, and tangent relates to orange ankles. This is just sort of setting you up so you can have an intelligent way of looking at it. It's like PEMDAS and Roy G. Biv and those kinds of things. Just helps you keep things straight. FOIL, stuff like that. Helps you keep things straight mathematically. So sine is going to be O and H, and cosine is going to be A and H, and tangent is going to be O and A, and we'll see that here. So sine is O and H, but the O and the H don't stand for orange horses, it stands for opposite and hypotenuse. And the always have, the AH doesn't stand for always have, it stands for adjacent and hypotenuse. And then the tangent is OA, which is opposite and adjacent. And those are ratios. We draw a fraction bar in here, we'll have a fraction, fraction, a fraction. We'll have relationships that are ratios. And you could see this here, if you could see it, you could see it a little bit bigger here, but it says that same thing, that the sine is orange horses, cosine is always have, tangent is orange ankles. So orange horses always have orange ankles. And it's just a way of keeping it straight, like I said. So we look at that in the practical sense then. We have these measurements, these known measurements of this particular right triangle. And it says express the sine of L. So this is the angle we're talking about. And when we look at sine, cosine, and tangent, you can produce this pretty quickly. Sine, cosine, and tangent. Orange horses always have orange ankles. Now, you could write it on every problem, which is what I'm going to have to do, probably. Or you could just write it like at the top of your paper or something and have it so you can glance at it, glance at it, glance at it, and that's typically what a student would do. But we can see in this case, because we're looking for sine, we're going to be doing O and H. So we look at this triangle, we look at this angle, you can see this is the hypotenuse, because it's always the one opposite the right angle. And then you got the two legs. Okay, the two legs always make the right triangle, or the right angle, the two legs. That's the opposite side, and this is the adjacent side. You should be able to see that. That's what we have already seen. Not, back up the video and watch it again. So the sine of L is opposite divided by hypotenuse. So for us, opposite is 12, hypotenuse is 37. And that is the sine of that angle. That's how you do it. That's how it works. Now, it's a super powerful thing. We're just beginning to peek in the window at how this would work. Super powerful thing that we do. You could take a whole class in trigonometry, literally. So now they want us to do the cosine of L. So it's the same angle, they want us to do cosine. So again, we have sine, cosine, tangent, orange horses always have orange ankles. So we're doing this one this time with the adjacent and hypotenuse. So we do the cosine of L, that's what they're asking us to do here. Cosine of L is going to be the adjacent divided by hypotenuse. So the hypotenuse is the hypotenuse, as I said. It is the hypotenuse. It's the one across on the right angle, period. So who's the adjacent for this one? 35. That's the answer. And so much more you can do with that, and we'll see a little bit of that later in the next lesson. So then we want us to do tangent. So sine, cosine, tangent. You can do the orange horses always have orange ankles. And we're doing L. So the tangent of L is equal to opposite, which is 12, divided by adjacent, which is 35. That's how that works. So it's pretty easy to see once you get used to doing this. Now what they're going to do here, and we won't take the time to do but just this first one, what they're going to do here is they're going to now flip the switch. Now we're not talking about angle L anymore, we're going to be talking about angle N. So with angle N, sine is still orange horses, always have orange ankles. And so now we're doing the sine of N, but when we look at, of course, hypotenuse is still 37, but when we look at the opposite for the N, we get 35. And you remember sine of L was 12 over 35. Anyway, there's some connections there that you'll see when you get to a pre-calculus class, that actually the sine of N is equal to the cosine of L. And again, you can back up the video if you want to see that. I'm not going to take the time to prove that out to you here. It's just how it works. So we could go through and have done all those different pieces. So here's just some more practice with this. We won't do all these either. But the sine, since the sine is orange horses, then in this case, the sine of angle A, that's this one. Of course, the hypotenuse is 20, period. Opposite of A is 12, which reduces, because both of those will divide by 4. I believe that's right. 3/5, which is answer B. Answer B. And you could go through that and do every one of these. It's the same stuff we just did. It's just practice that we could look at and relate to. And of course, they're going to be reducible fractions in most of those cases that we would have looked through and seen if we had this in a regular class. So I wanted to get to this one before we get done here. Because applications, of course, in this, in the real world, we talk about it all the time. You can know the measure of things that you can't measure. And that's the beauty of geometry, because you know relationships, we can know how these things relate or how they connect, and you can know something because of what you know that you wouldn't have known otherwise. It's pretty clever stuff. And so this, the problem says a fitness trainer sets the incline on the treadmill to 7 degrees. So you can sort of theorize and see this is the floor, this is the front, back, however you want to look at it, of the treadmill. This is where the person gets on, they raise that thing up, and when they do, they create a 7-degree angle right here. That's what that first part says. They've drawn a nice little picture for us. It says the walking surface is 5 feet long. They've labeled that. The walking surface is 5 feet long. It doesn't matter if it's laying on the floor or rising up in the air. It's still 5 feet. Like, it don't change, right? It does not change. How much the walking surface is how much the walking surface is. And it says approximately how many inches did the trainer raise the end of the treadmill from the floor? So this is the question. How far up do you have to raise that for that to be 7 degrees? Because it's probably going to be easier to raise the inch or measure the inches off the floor than it is the degrees here, because of the way it would work. So you could say, I want, this much degree incline. How far do I have to raise it up? And that's what we're looking at here. So when we look at this problem and we're talking about this angle, then we know this is the hypotenuse, right? It's a known piece, hypotenuse. And we know that this is the opposite side or opposite leg. Now this one's the adjacent one, but we don't know what it is and don't really care what it is at this point. So I'm just going to mark it out because it's irrelevant. So we look at this problem and go, well, we got an O and an H. Which trig function is that? O and H. Sine. Because we know that sine, cosine, tangent, those orange horses right there. There you go. Always have orange angles. So we know we're going to be doing sine. So we take the sine of 7 degrees is equal to, and we'll have opposite divided by hypotenuse. Now there's a trick to this problem, which is another reason that we need to do it besides just introducing the idea of applying it to word problems. There's a trick to this problem, and that is this. This is feet, the question is inches. And you can't compare apples and oranges here. So in this problem, what you need to do when you look at, if you want to know inches, that's the opposite, right? That's going to be the y. And then you've got the hypotenuse. It's 5 feet, but that's 60 inches. That way you have inches being compared to inches, not inches being compared to feet. And hopefully that just makes a ton of sense to you. But that's one of those things that will be hidden in a problem you have to be careful about, pay attention to. And so we have this. So here we are. We have an equation. Wow. An algebraic equation with an unknown variable, y. We want to find out what y is. So in algebra, we talked about having equations with fractions. You make the fractions disappear. How do you make the fractions disappear? Multiply both sides by the least common denominator. The only denominator is 60, so we'll multiply both sides by 60. These are going to cancel, so I'm going to get y. And then I have this thing here. It's 60 times sine of 7. Now, if you have a calculator, you could actually take and put that in the calculator. Type the 60, push the sine button, push the 7, and it's gonna give you an answer. It's probably gonna be a real long decimal answer. I will warn you that whatever machine or equipment you're using, sometimes there's, or most of the time, there's a degree mode. Also, there's a radian mode. We're talking about degrees here. In pre-calculus, you will talk about radians as well. You'll actually do both. We're talking about degrees. So you put that in degree mode, because you're talking about 7 degrees. You put it in and you have your answer, and that is your answer, how many inches tall that would have to be. And let's see, it kind of show you the keystrokes here, 60, sine of 7, and push enter, and you get this long decimal thing, and it rounded off to about 7.3 inches.